Hey y'all. Today's objective is exponential decay. And we are still using the exponential function y equals a times bx, where a is your initial amount, your starting value. B is your base or your rate or your percent. And in decay, your b value is going to be between 0 and 1. So just remember that you start at 100%, and then whatever it's decaying, you're going to take that away from the 100%. And then you have to change b to a decimal, and a is your initial amount. So example 1, the value of a new car decreases exponentially. Suppose you buy a car for $22,000. So if you're buying a car for $22,000, that would be your initial amount. So that's going to be your A. And the value decreases 20% per year. Write an equation to model the value in X years. Find the value after 6. That's a 6. So we have our A and we have our B. 100% minus 20% is going to be 80%. Now remember, when you have your decreasing value, you're going to start at 100, take away whatever it decreases, and you get 80. So when we plug it into our formula, first we have to write an equation. Y equals 22,000 times B, which is 80%. Remember, we need to bring it to a decimal. And then X. Sorry, get my calculator. All right, so there is our equation. Shows our initial amount, our base, and our value. And here would be your equation. To get the value after 6 years, you would plug a 6 in for X. So to find that value, it would be 22,000 times 0.8 to the 6th power. So we are going to calculate that first in our calculator. 0.8 to the 6th power. And then times 22,000. And y equals $5,767.17. So that is the value of the car after 6 years. So you can see from the time that you buy it at $22,000, after 6 years, it has definitely decayed. That's what's called exponential decay, is it starts to decrease to that amount, $5,767. Example 2, a stock is valued at $300. There's your initial amount. The value decreases by 9% per year. So every year it decreases 9%, 9%, 9%. Write an equation to find the value in X years. Find the value in 3.5 years, in 3.5 years. So when we substitute this in, my A is going to be $300. My B is going to start out at 100% minus 9%, which gives us a 91%. We want to write that value as a decimal, so 0.91. And then our time, our T, is going to be 3.5 years. So when we put it into our equation, y equals 300 times B, 0.91 to the x power. That would be your equation. To find the value at 3.5 years, you would substitute that in for your x. You would do this value first, so 0.91 to the 3.5 power times 300. And we would get $215.66. So that is how much it would be, the value of your stock after 3.5 years. It starts at 300, it's decreasing every year, and then after 3.5 years you would have $215.66. Example 3. Each year, a country club sponsors a tennis tournament. play starts with 128 players. So starts with 128 players. That would be your initial amount. And each round, half are eliminated. So one half, which would be 50%. How many players remain after 5 rounds? So there's your time that we're talking about. Not years, but rounds. So in this, we need to write an equation and then find how many people after 5 rounds. To do this, you would start with your equation, y equals. Your initial value is 128 times your b. So if we start with 100% and you are eliminating 50%, you're left with 50%. So this one's easy. 50% is a decimal. It's 0.5 to the x power. Here is our equation. 128 times 0.5 to the x power. The x power is the time period that we're talking about. And in this example, we're not talking about years, we're talking about rounds of a tennis tournament. So in the first round, or after the first round, you eliminate half. And then after that round, half more are gone. And in that round, half more are gone. So after 5 rounds, 128 times 0.5 to the 5th power. So then I would do this value first. 0.5 to the 5th power times 128, and it means there would be 4 players left after 5 rounds. All right. So those are some examples on exponential decay, and we're going to practice more in classes.